Hello everyone, welcome to SR Maths Learning channel. Today in this video we are going to discuss the trigonometric equations. So let's see what is the definition of trigonometric equations. So the equations which consist of trigonometric functions of unknown angles are known as trigonometric equations. So I'm writing the definition here. The equations involving trigonometric functions of unknown angles are known as trigonometric functions. So what is the meaning of this one? Generally, see, if I'll take the examples, cos theta is equal to 0. This is one trigonometric equation. Or cos square theta minus 4 cos theta is equal to 1. This is one trigonometric equation. Sin square theta plus sin theta is equal to 2. This is one equation. Means here if you'll see, first one is a linear equation in terms of cos theta. Second one is a quadratic equation in terms of cos theta. Third one is a quadratic equation in terms of sin theta. So here, these are the different kind of equations, but all are involving the trigonometric functions. So we know that trigonometric functions are periodic functions. So with the particular periods, like sin theta period is 2 pi, cos theta period is 2 pi, tan theta period is pi, like that. So the equations which are involving the trigonometric functions are known as the trigonometric functions. Trigonometric equations, known as trigonometric equations. So this is the definition, and these are the examples of trigonometric equations. So here, what is meant by solution? What is meant by solution? The value of this theta are unknown angles. We can say these are unknown angles. The value of the unknown angles that satisfy this equation is called as a solution of the particular trigonometric equation. So how can we write the definition is the value of the unknown angles that satisfies the equation is called a solution of that particular trigonometric function or trigonometric equation. So for example, what we took here, cos theta is equal to 0. So when you will get the cos theta is equal to 0, generally theta is equal to 90 degrees, not only for 90 degrees. So like that, many values will get the theta, cos theta as the 0, right? So this is called a solution. This theta is equal to 90 degrees is called a solution of this trigonometric equation. So this is, and another example we can take, sin theta is equal to 1 by root 2, where you will get 1 by root 2 in sin theta is equal to 45 degrees. So theta is equal to 45 degrees is a solution of this sin theta is equal to 1 by root 2. So this is called the solution of the trigonometric ratio. So let's see, one important thing is, so here for the every trigonometric ratio there may be infinity number of solutions. So the trigonometric equations may have infinite number of solutions. So generally, based on this, we can categorize two types of solutions. One is the principal solution. So another one is general solution. So what is meant by principal solution here? What is the definition of principal solution? And how can we find out the principal solution? So principal solution is numerically least angle. Numerically least angle. Numerically least angle is called principal value. Principal value. So what is meant by general solution? What is meant by general solution here? So the general solution is all the possible solutions of one particular trigonometric equation. So how can we define it? How can we write the definition? Is the solution consisting of all possible solutions of a trigonometric equation is called its general solution. So this is the way how we will define the two types of solutions for a trigonometric equations. One is principal solution, one is the general solution. So let's see general solution of some simple trigonometric equations. So general solution of some simple trigonometric equations. So let's see first general solutions of some simple trigonometric equations. So let's see first, and based on these concepts, we'll solve the problems next. Particularly when I have sine theta is equal to 0. So what is the general solution for this? Generally, sine theta is 0 where theta is equal to 0 degrees, and when it is pi, plus pi or minus pi, or plus 2 pi or minus 2 pi, plus or minus 3 pi. So like this, for every integral multiples of pi, sine theta will be 0. So like this, what will be the nth term we can take? N pi we can take. So that means theta belongs to n pi. We have to define what is the n value. N is here integers. So that may be plus or minus values. So the general solution of sine theta is equal to 0. If sine theta is equal to 0, then theta is equal to n pi, where n belongs to integers. So this is the first one. Next, we have cos theta is equal to 0. So where we can observe the cos theta is equal to 0 generally. So for the angle, theta is equal to pi by 2. For theta is equal to pi by 2, or 3 pi by 2, 5 pi by 2, or minus pi by 2, minus 3 by 2, means all the multiples of odd multiples of 90 degrees. For all the odd multiples of 90 degrees, means pi by 2, we'll get the cos theta value as the 0. So generally, the general form of odd multiples is, how can we take, is 2n plus 1 into pi by 2. So where n belongs to integers. So if you want, you can solve it. This substitute n is equal to 0 here, we'll get pi by 2. When n is equal to 1, so it will be 3 pi by 2. When n is equal to minus 1, so minus pi by 2. So like this, we'll get the, for different values of n, different angles, theta values we will get. So for these all odd multiples of pi by 2, we will get the cos theta as the 0. So let's see the third one. So what is the third one? Is tan theta is equal to 0. So where you will get the tan theta is equal to 0, this is also, everyone know that when theta becomes pi, so that's, I'm taking n pi, where n belongs to I, so tan theta will become the 0. So this is a general solution for tan theta is equal to 0. So next we will see when sine theta is equal to sine alpha. When sine theta is equal to, means if sine theta is equal to sine alpha, so what is the general solution? So let's we try to derive it. So we know that we have here sin theta minus sin alpha is equal to 0, right? So here we know one formula, that sin c minus sin d. So what is the sin c minus sin d formula? 2 cos c plus d by 2 sin c minus d by 2. So we will use this formula. So we'll use this formula to find out the sin theta minus sin alpha. So according to this, 2 cos theta plus alpha by 2 sin theta minus alpha by 2 is equal to 0. So this we can take like cos of theta plus alpha by 2 is equal to 0, or sin of theta minus alpha by 2 is equal to 0. Means if any one of these trigonometric function is 0, the product will be 0, or both can be 0, So just now we learned, when cos theta is equal to 0, theta is equal to 2n plus 1 into pi by 2, where n belongs to I. So this is what we learned just now for cos theta is equal to 0. So here in the place of cos theta, we have theta plus alpha by 2. So that means we can write this one, we can apply for this, like theta plus alpha by 2 is equal to 2n plus 1 into pi by 2. 2n plus 1 into pi by 2. So this we can write like theta plus alpha is equal to, when I will multiply the 2 here, so otherwise this 2 into 2, so 2 and 2 gets cancelled. We will get theta plus alpha is equal to 2n pi plus pi. Otherwise we can simply write 2n plus 1 into pi. So this we can write theta is equal to 2n plus 1 pi minus alpha. So let it be 1. So another one, what we have here, sin of theta minus alpha by 2 is equal to 0 we have. So from here, we already know that just now we learned sin theta is equal to 0 means theta is equal to n pi, where n belongs to z or I, we can say integers. So according to this, we can apply theta minus pi by 2 is equal to n pi is equal to, so n pi we will get. So from here, theta minus alpha is equal to 2n pi. So from here, theta is equal to, we'll get 2n pi plus alpha. So this is where n belongs to integers. So let it be equation 2. So if you'll observe the equation 1 and equation 2. So in the equation 1, any odd multiple of pi, minus alpha. And the second one, we got any even multiple of pi plus alpha. So this is what we got. So from these two, what we can take, so it will be n pi plus minus 1 whole power n alpha, where n belongs to integers. So therefore, if sin theta is equal to sin alpha, so general solution for this one is theta is equal to n pi plus minus 1 whole power n into alpha, where n belongs to integer and alpha belongs to minus pi by 2 to pi by 2, So this is the general solution of when sin theta is equal to sin alpha and its proof. So next, cos theta is equal to cos alpha, let's say. So if we have cos theta is equal to cos alpha, what is the general solution for this one? So this is also in the similar way, we can take like cos theta minus cos alpha is equal to 0. So what we have the formula for cos c minus cos d? Cos c minus cos d, we have minus 2 sin c plus d by 2 into sin c minus d by 2. So this formula, if you apply here, so what you will get, minus 2 sin theta plus alpha by 2 into sin theta minus alpha by 2 is equal to 0. So the product of these two is 0, means either we can say theta plus alpha by 2 is equal to 0, or we can say sine of theta minus alpha by 2 is equal to 0. So any one of these is equal to 0, then the product also 0. So or both can be 0. So from here, what we can write? So we know that sine theta is equal to 0, means theta is equal to n pi, where n belongs to integers. This if we'll apply here for this and this both, for the both. So what we'll get is theta plus alpha by 2. In the place of theta, we have here theta plus alpha by 2. So that's why it will become theta plus alpha by 2 is equal to n pi. That means we will get theta plus alpha is equal to 2n pi. Theta is equal to 2n pi plus alpha. So let it be 1. So from the first condition, we will get theta is equal to 2n pi plus alpha. So if you look at the second one, here also we can apply the same condition, general solution. So we'll get theta minus alpha by 2 is equal to n pi. So theta minus alpha is equal to 2n pi. So from here theta is equal to 2n pi plus alpha. From here we can say theta is equal to 2n pi plus alpha. If you look at the equation 1 and 2, so from equation 1 and 2, so we can finalize that theta will be 2n pi plus or minus alpha, where n belongs to integer and where alpha satisfies closed interval 0 to pi. So in this case, so this is the general solution of the cos theta is equal to cos phi. So we can say when cos theta is equal to cos phi, so cos alpha, this is the general solution. This is the general solution. So hope you understand how to take the general solution and how to derive it. So next, third one in this, if tan theta is equal to tan alpha, if tan theta is equal to tan alpha, so what is the general solution? If tan theta is equal to tan alpha, so what is the general solution? So let's see here, tan theta is equal to tan alpha, we have tan theta is equal to tan alpha, we have where alpha belongs to open interval minus pi by 2 to where alpha belongs to open interval minus pi by 2 to pi by 2. So this I can change like sin theta by cos theta is equal to sin alpha by cos alpha. So cross multiply this one, you will get a sin theta cos alpha is equal to cos theta sin alpha. So that is equal to sin theta cos alpha minus cos theta sin alpha is equal to 0 we will get. So is equal to 0 we will get here. So how can we write this one? So this can be written as sin of theta minus alpha is equal to 0. So we know that the general solution when sin theta is equal to 0 is the theta is equal to n pi, where n belongs to integers. So let's we apply this here, we'll get theta minus alpha is equal to n pi. So from here theta is equal to n pi plus alpha, where n belongs to integer. So this is the general solution for tan theta is equal to tan alpha. So therefore we can finalize if tan theta is equal to tan alpha, then general solution will be theta is equal to n pi plus alpha, where n belongs to integers, So let's solve the problems based on this for the conceptual clarity to understand more. So let's see the examples. So first example. So examples. First example, find the general solution. Find the general solution of the equation. Find the general solution of the equation sin x plus sin 3x is equal to 0. So for this we have to find out the general solution. So let's see So what is the solution for this one? So solution for this one is, let's we take first sine 3x plus sine x is equal to 0. So we know sine c plus sine d is equal to 2 sine c plus d by 2 into cos c minus d by 2. So let's we use this formula to solve this one. So we'll get 2 sine 3x plus x by 2 into cos 3x minus x by 2 is equal to 0. So this we can write 2 sine 4x by 2 means 2x, and 2x by 2 is x is equal to 0. So any one of these can be 0 or both can be 0, then product will be 0. So case 1 what we can take is sine 2x is equal to 0, and case 2 we can take cos x is equal to 0. So sine 2x is 0 means what we learned just now, when sine theta is equal to 0, theta is equal to n pi, where n belongs to integers. So according to this, so I can write 2x is equal to n pi, from where x is equal to n pi by 2 and n belongs to integers. And what next, second case is cos x is equal to 0. So cos x is equal to 0 means cos theta is equal to 0 means theta is equal to 2n plus 1 into pi by 2, where n belongs to integers. So this is the condition, general solution condition for cos theta is equal to 0. So from here we will get direct x is equal to 2n plus 1 into pi by 2, where n belongs to integers. So what is the general solution which satisfies the both? So general solution which satisfies the both is x is equal to n pi by 2, where n belongs to integers. So this is the general solution or answer for this question. So this is the way how to solve this question. So next question number 2. So what is the question number 2? Find the general solution of the following equations. So find the general solutions of the following equations. So here I have different questions. So let's see how to solve this one. In the first one is, if sine theta is equal to root 3 by 2. So what is the general solution for this one? So how can we write this one? Sine theta is equal to root 3 by 2, where you will get root 3 by 2 in sine for 60 degrees. So that can be written as sine pi by 3. So sine theta is equal to sine pi by 3 I got. So when sine theta is equal to sine pi by sine alpha, so what we discussed the general solution, theta is equal to n pi plus minus 1 whole power n into alpha. N pi plus minus 1 whole power n into alpha. If you solve according to this, we'll get theta is equal to n pi plus minus 1 whole power n into pi by 3, because alpha value here is pi by 3. So this is a general solution for this, where n belongs to integer. See, here we have to remember one thing is, unless they will mention the what is a small n, so default it is n belongs to integers. You have to assume. So this is the way how we will solve the sine theta is equal to root 3 by 2 and its general solution. So let's see one more question in this. Sine 2x is equal to root over root minus 1 by 2 root 2. So what is the angle to take here to get the root 2? Square root of root 2 minus 1 by 2 root 2 is pi by 8. So pi by 8 means how much? So pi by 4 is the 45 degrees. Pi by 8 is 22.5 degrees. So sine 22.5 degrees, you will get root over root 2 minus 1 by 2 root 2. So how can we write this one? Sine 2x is equal to, the value of this one is sine pi by 8. So here we can apply the formula. Sine theta is equal to sine alpha, then theta is equal to n pi plus minus 1 whole power n into alpha. So this is equal to, we can apply here 2x is equal to n pi plus minus 1 whole power n into pi by 8. So, but we want only x value here. So, divide both sides by 2, you will get n x is equal to n pi by 2 plus minus 1 whole power n into pi by 16. Minus 1 whole power n into, so pi by 16. So, this is the solution for this question. Okay, so let's see. Let's see how to solve the next question. So I have one more question here in a similar way. So that question is sine 2 theta is equal to root 5 minus 1 by 4. Root 5 minus 1 by 4. So we know that very clearly because in the trigonometry we discussed sine 18 value is nothing but root 5 minus 1. So sine 18 value is root 5 minus 1 by 4. So how can we write sine 18 is pi by 10? So we can write like pi by 10. So here sine 2 theta is equal to root 5 minus 1 by 4, which is equal to sine pi by 10. So we know sine theta is equal to sine alpha, means theta is equal to n pi plus minus 1 whole power n into alpha, where n belongs to integer. So this is the condition we know. So according to this condition, we write 2 theta is equal to n pi plus minus 1 whole power n into pi by 10. So we need the only theta value here. So theta will be n pi by 2 plus minus 1 whole power n into pi by 20. Pi by 20. So this is the way how we'll find. So let's see one problem in cos terms, in terms of cos. So question number D in the second way. Cos theta is equal to minus 1 by root 2. So generally where theta lies, if you'll write like this one, cos theta is equal to minus 1 by root 2 is equal to cos 3 pi by 4, we can write. Because theta belongs to here, alpha belongs to, so here alpha belongs to 0 to pi only. So whatever we are taking the value for this minus 1 by root 2, we should take 0 to pi only. Because why I am mentioning this one is, cos is negative in Q2 and Q3 also. So if you will not mention the condition here clearly, so that angle I can take in the Q3 also. So that's why your conditions are very much important. So where alpha lies is 0 to pi, closed interval. So now this is in the form of cos theta is equal to cos alpha. So for this theta is equal to, we have 2n pi plus or minus alpha, where n belongs to integers. So this is the condition for cos, general solution. So now we can write from this one, theta is equal to 2n pi plus or minus 3 pi by 4. So where n belongs to integers, So this is the way how we will apply these general solutions, how we will apply the conditions, and how we can find the general solutions. So let's see one trigonometric equation. So that solve 2 cos square theta plus 11 sin theta is equal to 7. So let's observe here. This is the one trigonometric equation which is quadratic. But if you'll observe clearly, whatever they are given here, both are not same trigonometric functions. So one is sin theta, one is cos theta. So whenever you will see these kind of questions, first you have to change that all the trigonometric ratios into same trigonometric ratios. So what is the chance of changing here? So if you'll see the solution, sin theta, if I'll try to change in terms of cos, so I'll get in terms of root. So that is little danger, means we are becoming more complicating the question. So we are changing into complication. So that's why better to change cos square theta into sin times. So I'll note down the question first. 2 cos square theta plus 11 sin theta, I can write minus 7 is equal to 0. So we know that sin square theta plus cos square theta is equal to 1. So from here I can write cos square theta is equal to 1 minus sin square theta. So I can write from here sin cos square theta is equal to 1 minus sin square theta. So from here 2 into cos square theta can be written as 1 minus sin square theta plus 11 sine theta minus 7 is equal to 0. So from here we can write 2 minus 2 sine square theta plus 11 sine theta minus 7 is equal to 0. So this we can write minus 2 sine square theta plus 11 sine theta. So here 2 minus 7 is minus 5 is equal to 0. So how can we write this one? 2 sine square theta minus 11 sine theta plus 5 is equal to 0. So let's we factorize this one. This is a quadratic equation in terms of sine. So if we'll factorize this one, we will get 2 sine square theta. So 2 5 is 10 here. So that's why I can write the middle term like minus 10 sine theta minus sine theta plus 5 is equal to 0. So from these two, I can take 2 sine theta common. So left out in the first term is sine theta and in the second term is minus 5. So from the next two terms, I can take the minus 1 common. So I'll get again sine theta minus 5 is equal to 0. So this is equal to, from these two, I can take the common sine theta minus 5 into 2 sine theta minus 1 is equal to 0. So from here, I will get sine theta is equal to 5. And other case is 2 sine theta minus 1 is equal to 0. From where you will get sine theta is equal to 1 by 2. So this condition is not at all possible because we know very well sine theta value is lies between minus 1 and 1 only. So this case is not possible. So let's look at this case. So if sine theta is equal to 1 by 2, 1 by 2 where we will get in the in terms of sine 30 degrees. So that can be written as a sine pi by 6. So here we can apply the formula sine theta is equal to sine alpha. Then theta is equal to n pi plus minus 1 whole power n into alpha. So minus 1 whole power n into alpha. So let's apply this for this one. So we'll get theta is equal to n pi plus minus 1 whole power n into pi by 6, where n belongs to integer. So this is the way how we will solve this trigonometric equation. So hope you understand very clearly. So let's see one more question. So next question is, solve the equation tan square theta minus secant theta is equal to 1. Tan square theta minus secant theta is equal to 1. So let's see how to solve this question. So solution for this question is, first what we have, what they're given is sin square theta minus secant theta is equal to 1. So this we can write like tan square theta minus secant theta minus 1 is equal to 0. So this we can write like tan square theta we can change in terms of secant. What we know formula is secant square theta minus tan square theta is equal to 1. So from here tan square theta you will get secant square theta minus 1, that is equal to tan square theta. So let's substitute this. So completely it will change it into the secant terms. So you can write here secant square theta minus 1. Already we have minus secant theta minus 1 is equal to 0. So this we can write secant square theta minus secant theta minus 2 is equal to 0. So we are not studied any general solution for secant theta. So that let's try to change what we know. That means secant theta we can substitute secant theta, we can substitute 1 by cos theta. So let's substitute here. So what you will get is 1 by cos square theta, 1 by cos square theta minus 1 by cos theta minus 2 is equal to 0. Minus 2 is equal to 0. So if I'll simplify this one, I'll get 1 minus cos theta, 1 minus cos theta minus 2 cos square theta is equal to 0. 1 minus cos theta, divided by, we'll get cos square theta. So here where cos theta is not equal to 0. So here cos theta is not equal to 0 condition. So let's send that other side. So we'll get 2 cos square theta if we'll multiply with minus plus cos theta minus 1 is equal to 0. So this is what we will get. So how can we factorize this one? This is a quadratic equation in terms of cos. So we can factorize this one as 2 cos square theta plus 2 cos theta minus cos theta minus 1 is equal to 0. So from the first two terms, I can take 2 cos theta common, then cos theta plus 1 will be left out. From the next two terms, I can take the minus 1 common. So you'll get cos theta plus 1 will be left out in this. So from both, I can take cos theta plus 1 as the common. So we'll get 2 cos theta minus 1 is equal to 0. So from here, one case we'll get cos theta plus 1 is equal to 0. Another case we'll get 2 cos theta minus 1 is equal to 0. 2 cos theta minus 1 is equal to 0. So this is, from this we'll get cos theta is equal to minus 1. So where we will get a minus 1 in 0 to pi is pi, cos pi value. So because here alpha belongs to 0 to pi. So then we can write theta is equal to 2n pi plus or minus pi, where n belongs to z or integers I. So this is the first case. So what is the second case? 2 cos theta minus 1 is equal to 0. From where you will get cos theta is equal to 1 by 2. This is possible for cos 60. So we can write cos pi by 3. So here also theta is equal to 2n pi plus or minus pi by 3, where n belongs to integers. So these are the two different general solutions. What you will get for the given question, tan square theta minus secant theta is equal to 1. So this is the one more question. Next topic. Next topic. So what is the next topic is, if sin square theta is equal to sin alpha. If sin square theta is equal to sin alpha, what happens? These are the three different conditions for which general solution is common. If sin square theta is equal to sin square alpha, or cos square theta is equal to cos square alpha, or tan square theta is equal to tan alpha, tan square alpha. For this all, general solution is same, that theta is equal to n pi plus or minus alpha. So let's see how we will get this for different trigonometric equations here. So the first one, sin square theta is equal to sin square alpha. This is the first one. Sin square theta is equal to sin square alpha. So here, how can I write the sin square theta is equal to sin square alpha is, we have one formula that sin square theta is equal to 1 minus cos 2 theta by 2. So according to this formula, I will write this one as 1 minus cos 2 theta by 2 is equal to this. I can write 1 minus cos 2 alpha by 2. 1 minus cos 2 alpha by 2. So both sides, this 2 and gets cancelled, and 1 and minus also gets cancelled. You'll get cos 2 theta is equal to cos 2 alpha. So what is the general solution for cos theta is equal to cos alpha? Theta is equal to 2n pi plus or minus alpha, where n belongs to integers. So this is the condition. So according to this, we can write 2 theta is equal to 2n pi plus or minus 2 alpha. So from where theta is equal to n pi plus or minus alpha, where n belongs to integers. So this is what we will get. So this is the way how we will get theta is equal to n pi plus or minus alpha for the sin square theta is equal to sin square alpha. Next we will see cos square theta is equal to cos square alpha. So for this, how we will get theta is equal to n pi plus or minus alpha. How we will get? Let's see, where n belongs to integer default. So here we can write this one as we have formula cos square theta is equal to 1 plus cos 2 theta by 2. So according to this formula, we can write this one as 1 plus cos 2 theta by 2 is equal to 1 plus cos 2 alpha by 2. So 2 gets cancelled, plus 1 and plus 1 gets cancelled. So we'll get cos 2 theta is equal to cos 2 alpha. So again same, so we can write general solution as 2 theta is equal to 2n pi plus or minus 2 alpha, because if cos theta is equal to cos alpha, theta is equal to 2n pi plus or minus alpha. So this is the general solution. So from here we'll get theta is equal to n pi plus or minus alpha, where n belongs to z, so integers. This is the second one. So let's see third one. What is the third one is tan square theta is equal to tan square alpha. Tan square theta is equal to tan square alpha. So when you will get this one, so how can we change this? So let's see, apply the component and dividend for this one. So applying applying componendo and dividendo. What is this? If a by b is equal to c by d, then you will apply the component dividendo, you will get a plus b by a minus b is equal to c plus d by c minus d. Or you can write like a minus b by a plus b is equal to c minus d by c plus d. This is called component and dividend. So let's say apply this for here. You will get 1 minus tan square theta by 1 plus tan square theta is equal to, because it will be by 1, so we can write 1 minus tan square alpha by 1 plus tan square alpha. So we know that this is the formula of cos 2 theta. This is the formula of cos 2 alpha. So from here, the general solution will be 2 theta is equal to 2n pi plus or minus 2 alpha. So from where you will get theta is equal to n pi plus or minus alpha, where n belongs to integer. So hope everyone clear with this. So here we are finalizing. So we got, if sin square theta is equal to sin square alpha, or cos square theta is equal to cos square alpha, or tan square theta is equal to tan square alpha. So whichever in this, theta will be n pi plus or minus alpha. N pi plus or minus alpha is the general solution, where n belongs to integers. So this is the concept. Let's see the problems based on this topic. So what are the problems we have here is first question. So examples. In examples, first question, find general solution of sin square theta is equal to 1 by 2. Sin square theta is equal to 1 by 2. So see here, when we can apply this formula, so you should understand. So wherever directly they will give squares for the trigonometric ratios, better to convert them into sin square theta is equal to sin square alpha, or cos square theta is equal to cos square alpha, like that. So here we have sin square theta is equal to 1 by 2. So this I have to convert to sin square theta is equal to sin square alpha. So how to convert? So what I will do is, for this 1 by 2, I will write 1 by root 2 whole square. So 1 by root 2 whole square in the sense that is 1 by 2 only. So this is the way how can we change. So sin square theta is equal to 1 by root 2, where we will get in the sin terms, sin 45. So we can write this one as sin pi by 4 whole square, which can be written as sin square pi by 4. So this we can write like this. So now we are changing into sin square theta is equal to sin square alpha. Then theta is equal to what? N pi plus or minus alpha. Theta is equal to n pi plus or minus alpha. Therefore, the general solution for this one is theta is equal to n pi plus or minus pi by 4, where n belongs to integers. So this is the general solution. This is the general solution for this question. Let's see one more question. So one more question is here. Find the solution set of tan square theta is equal to 3. So let's see what they are given the solution. Question. What is the solution for this one? So they are given tan square theta is equal to 3. So 3, how can we change it into tan square theta is equal to tan square alpha is 3 can be written as root 3 whole square, right? So again, if you simplify this one, we will get 3 only. So from here we can write that tan square theta is equal to root 3, where we will get in tan terms is for 60 degrees. So we can write that one as tan of pi by 3 whole square. So which can be written as tan square pi by 3. So now formula for this one also, theta is equal to n pi plus or minus alpha. So we'll get theta is equal to n pi plus or minus pi by 3, where n belongs to z, so integers. So this is the way how we will solve this one. So let's see next question. So what is the next question is solve 7 sin square theta plus 3 cos square theta is equal to 4. So how to solve this kind of questions? See, anyone, we have to change it into another equation. So what I will do is 7 sin square theta plus 3 into, so what we can write in place of cos square theta is sin square theta plus cos square theta is equal to 1. So from here, cos square theta will be 1 minus sin square theta. Cos square theta will be 1 minus sin square theta. So according to this, we can write 1 minus sin square theta is equal to 4. So this is equal to 7 sin square theta plus 3 minus 3 sin square theta is equal to 4. So from here we will get 4 sin square theta is equal to 4 minus 3, which is 1. So from where you will get sin square theta is equal to 1 by 4, which can be written as 1 by 2 whole square. So 1 by 2, where we will get in sine for 30 degrees. So sin square theta is equal to sine pi by 6 is 30 degrees whole square. So that is equal to, we can write sine square pi by 6. We can write sine square pi by 6. So from here we can write theta is equal to n pi plus or minus pi by 6, where n belongs to z, where n belongs to z. So this is the way how we can solve problems like this. So next, so we have these kind of questions also. So we'll get these kind of questions also. So the questions are like this, based on the same thing. One more question based on the same topics. So the question is sin phi theta is equal to cos 2 theta. Sin phi theta is equal to cos 2 theta. So what is the theta here? How many number of solutions are possible? So number of solutions possible here. We need to find the number of solutions possible for this one. So what I can do here is, sin phi theta is equal to cos 2 theta. We know that cos 90, sin 90 minus theta is equal to plus cos theta, correct? So according to this, from here to here, I'm going to write this one. So that means I'll write this one as sin over pi by 2 minus 2 theta. Sin over pi by 2 minus 2 theta. So what we have here? Otherwise, better let's change this to cos. It will become more easy. So according to this one. So if we'll change this into cos, so it will become cos of pi by 2 minus phi theta is equal to cos 2 theta. So we know that cos theta is equal to cos alpha. Cos theta is equal to cos alpha. From here we will get theta is equal to 2n pi plus or minus alpha. So here this will write like this: cos 2 theta is equal to cos of pi by 2 minus phi theta, whichever the way we will write, same thing you will get. So here we can write this one according to this formula. 2 theta is equal to 2n pi plus or minus pi by 2 minus phi theta. Pi by 2 minus phi theta. So here let's substitute different values for n. So if I substitute n is equal to 0, you'll get 2 theta is equal to plus or minus pi by 2 minus phi theta. So in this, if I'll take first case, 2 theta is equal to plus, if I'll take pi by 2 minus phi theta will get. So from here 7 theta is equal to pi by 2. Theta is equal to pi by 14, one solution. So this is lies between pi minus pi by 2 to pi by 2 only. So if I'll case 2 here, if I'll take 2 theta is equal to minus, it will become minus pi by 2 plus phi theta. So from here 3 theta is equal to pi by 2. Theta is equal to pi by 6. So next, if I'll substitute n is equal to 1, if I'll substitute n is equal to 1, it will become 2 theta is equal to 2 pi plus or minus pi by 2 minus phi theta. So theta is equal to what you will get? Pi plus or minus pi by 4 minus phi theta by 2. So if I'll remove this plus or minus once case 1, theta is equal to pi plus pi by 4 minus 5 theta by 2. So from here, theta plus 5 theta by 2 is equal to 5 pi by 4. So here 7 theta by 2 is equal to 5 pi by 4. We will get 2 ones are 2 twos are. Theta is equal to 5 pi by 14. We will get one answer. So another answer is theta is equal to pi minus pi by 4 plus 5 theta by 2. So this will be theta minus 5 theta by 2 is equal to 3 pi by 4, which you will get minus 3 theta by 2 is equal to 3 pi by 4. So 2 cancel, 3 cancel. We'll get theta is equal to minus pi by 2. Theta is equal to minus pi by 2. So if I'll substitute n is equal to minus 1, if I'll substitute n is equal to minus 1. So what you'll get, theta is equal to 2 theta is equal to minus 2 pi plus or minus pi by 4 minus 5 theta by 2. So when I'll take the positive, I'll get 2 theta is equal to minus 2 pi plus pi by 4 minus, 5 theta only here, minus 5 theta. This will become pi by 2, sorry, because we are not taking the 2 common yet. So this will become 7 theta is equal to minus 2 pi means minus 4 pi. So minus 3 pi by 2, minus 3 pi by 2 will get. So from here theta is equal to minus 3 pi by 14. Okay. So what is the another one we'll get when I will take the minus 2 theta is equal to minus 2 pi minus pi by 2 plus 5 theta. So from here we'll get 3 theta is equal to 5 pi by 6, which not belongs to minus pi by 2 to pi by 2. So that's why this solution is not possible. So how many solutions we got here? So we got a total 5 solutions. So 5 solutions are possible. 5 solutions are possible for this question. So hope you understand this one. So how to solve this one? So let's see one statement type of question. So what is this question is? S1 statement 1 is, if tan p theta is equal to cot q theta, then they are given theta is equal to 2n plus 1 by pi by 2 times of p plus q. This is a statement 1. Statement 2, if tan theta is equal to, if tan pi sin theta is equal to cot pi cos theta. So then sin theta plus pi by 4 is equal to plus or minus 1 by 2 root 2. Plus or minus 1 by 2 root 2. So this is the statement 1, statement 2. So here options are, both are true. Statement 1 is true, statement 1 is, we have options like this. Option A is both S1 and S2 are true. Option B, S1 is true, S2 is false. Option C, S1 is false, S2 is true. Option D, S1 and S2 both are false. So let's see. Let's try to simplify this one. So statement 1 first. So what we have, statement 1, tan p theta is equal to cot q theta. So how can we write this cot q theta? So tan p theta is equal to tan 90 minus q theta, which is nothing but cot q theta. So this is equal to, we have tan theta is equal to tan alpha, means theta is equal to n pi plus alpha, where n belongs to integers. So according to this, I can write p theta is equal to n pi plus pi by 2 minus q theta. So this is equal to p theta plus q theta is equal to, we can take pi common and we can simplify this, 2n plus 1 by 2 into pi we will get. So from here theta will be p plus theta into p plus q is equal to 2n plus 1 into pi by 2. So how can we finalize the theta here? Theta is equal to 2n plus 1 into pi by 2 into p plus q. So statement 1 is true. Statement 1 is true. So next let's see statement 2. What is the statement 2 we have? So tan pi sin theta is equal to cot pi cos theta. Cot pi cos theta. So this how can we write? Tan pi sin theta is equal to tan 90 minus pi cos theta. That is nothing but cot only. So we know tan theta is equal to tan alpha. Theta is equal to n pi plus alpha, where n belongs to z. So according to this, I can write this one as pi sin theta is equal to n pi plus pi by 2 minus pi cos theta. Pi by 2 minus pi cos theta. So this, how can we simplify this minus pi cos theta transpose to this side? So we'll get pi sin theta plus pi cos theta is equal to n pi plus pi by 2. So from here, if I'll take the pi common, we'll get a sin theta plus cos theta. So from RHS also I can take the pi common. So we'll get 2n plus 1 by 2. 2n plus 1 by 2. So this and this cancel. Pi and pi both sides. So what you'll get? What you'll get? Only left out is sin theta plus cos theta is equal to 2n plus 1 by 2. So this what we will do is divide with root 2 on both sides. So when you will get this kind of situation, combination of sin theta and cos theta, divide with root 2. So you'll get 1 by root 2 into sin theta plus 1 by root 2 into cos theta is equal to, you will get 2n plus 1 by 2 root 2. So this I can write sin theta cos pi by 4, that is 1 by root 2, plus cos theta into 1 by root 2, I can write sin pi by 4 is equal to 2n plus 1 by 2 root 2. So this is sin A cos B plus cos A sin B. So this is the formula of sin A cos B plus cos A sin B. So which can be written as sin A plus B. Sin A plus B. So according to this formula, so we can write this one as sin of theta plus pi by 4, that is equal to what you will get 2n plus 1 by 2 root 2. So if I'll substitute n is equal to 0, if I'll substitute n is equal to 0, we will get sin theta plus pi by 4 is equal to 1 by 2 root 2. So 1 by 2 root 2. So if I'll substitute n is equal to minus 1, if I'll substitute n is equal to minus 1, so I'll get sin theta plus pi by 4 is equal to minus 1 by 2 root 2. So therefore, by this we can conclude that sin theta plus pi by 4 will be plus or minus 1 by 2 root 2 we can take. Plus or minus 1 by 2 root 2 we can take the solution for this one. So hope you understand this problem. So next, let's see one more question. So after that, we'll take some questions as a homework. So let's see this question. One more question. Question number is tan theta plus tan 2 theta plus tan 3 theta is equal to 0. So we need to find the theta, general solution for theta. So how can we solve this one? So solution for this one is tan theta plus tan 2 theta formula is 2 tan theta by 1 minus tan square theta plus tan 3 theta formula is 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta, that is equal to 0. So from here, I can take the tan theta common. So what will be left out is 1 plus 2 by 1 minus tan square theta plus 3 minus tan square theta by 1 minus 3 tan square theta. 1 minus 3 tan square theta, that is equal to 0. That is equal to 0. So from here, I can take tan theta is equal to, tan theta into, if I take the LCM here, denominator, I'll get 1 minus tan square theta into 1 minus 3 tan square theta, 1 minus 3 tan square theta. So here this 1 will be multiplied with the both. So 1 minus tan square theta into 1 minus 3 tan square theta plus 2 into, here it will be 1 minus 3 tan square theta plus 3 minus tan square theta. So into 1 minus tan square theta, 1 minus tan square theta is equal to 0. So if we'll simplify this one, so tan theta into, so this will be not equal to 0. When you send other side, it will become 0. So numerator, if you multiply 1 minus 3 tan square theta minus tan square theta plus 3 tan power 4 theta plus 2 minus 6 tan square theta plus 3 minus 3 tan square theta. So minus tan square theta plus tan power 4 theta is equal to 0. From here, we can write this one as tan theta into, so we can write this one as 4 tan power 4 theta minus 14 tan square theta plus 6 is equal to 0. So we can take this one as case 1, tan theta is equal to 0, and case 2, I can take 4 tan power 4 theta minus 14 tan square theta plus 6 is equal to 0. So this is a case 2. So this is case 1. So from here, theta is equal to n pi, where n belongs to integers. So we know very well. So comes to here, I will take the 2 common. So I'll get 2 tan power 4 theta minus 7 tan square theta plus 3 is equal to 0. So 2 3 is 6 here. So middle term we can split like 2 tan power 4 theta minus 6 tan square theta minus tan square theta plus 3 is equal to 0. So from here, if I'll take 2 tan square theta common, I'll get tan square theta minus 3 minus 1 into, so if I'll take minus common, so it will become tan square theta minus 3 is equal to 0. So from here, tan square theta minus 3 into 2 tan square theta minus 1 is equal to 0. So from here we'll get, so one condition is tan square theta minus 3 is equal to 0, or 2 tan square theta minus 1 is equal to 0. So from here, what we can do, from here tan square theta is equal to tan square alpha. So we'll get tan square theta is equal to 3, which can be written as root 3 whole square. Already we saw the solution for this one previously. So theta is equal to n pi plus or minus pi by 3 you will get. So this is one solution. So from here, tan square theta is equal to 1 by 2. So from here, theta is equal to what we will get, n pi plus or minus tan inverse of 1 by root 2 we will get. So this is the way how we will find out the solution set for this one. So finally, we can finalize the solution set as the theta is equal to n pi by 3 or n pi plus or minus tan inverse 1 by root 2. So these are the solution for general solution for this question. So hope everyone understood. So here I will give you some homework questions. So please solve this one, and we can discuss these questions in the next video. So homework questions. So first one, if mod of tan x is equal to tan x plus 1 by cos x, and x belongs to 0 to 2 pi, 0 to 2 pi, and x not equal to pi by 2 and 3 pi by 2, then find values of x. Find values of x. Number of solutions of the equation tan x plus secant x is equal to 2 cos x lying in the interval 0 to 2 pi, open is. So please solve these two questions. So we'll discuss these questions in the next video. So thank you all for watching my videos, and thanks for encouraging SR Maths Learning channel. Please support my channel and please share these videos to your friends and family members. Please subscribe to my channel if you are not yet subscribed. Thank you all.